Hi guys, so here I have a question for you and it is based on the beta and gamma function. So the given term is integration 0 to infinity x raised to p minus 1 upon 1 plus x dx is equal to pi upon sine p pi. So the value of the integration is given and we have to prove that gamma p into gamma 1 minus p is equal to pi upon sine p pi. Now guys, let me tell you that this is one of the important property of gamma function which is used to evaluate multiple numericals. So now we will derive this property by using or with the help of the given integration. So let's start with it. So since the value is given as pi upon sine p pi, so what we have to do is we just have to prove that this value, that is the integration, evaluates to gamma p into gamma 1 minus p, because if it is equal to gamma p into gamma 1 minus p, we can easily say that it is equal to pi upon sine p pi. So it's so simple. So let's start with the integration. So for that, first of all, I'll consider the given integration as I. So here I'll say I is equal to integration from 0 to infinity x raised to p minus 1 upon 1 plus x dx. Now guys, to evaluate this integration, if you see the limits, it is from 0 to infinity, and whenever the limit is from 0 to infinity and if I want to solve the integration, it always reminds me about one of the substitution which is x equal to tan theta or x equal to tan square theta, because I know that tan inverse of 0 is 0 and tan inverse of infinity is pi by 2, so it can give me 0 to pi by 2 limits. And if you'll see here, then yes, definitely we can substitute x as tan square theta. Now why x as tan square theta? Because 1 plus tan square theta can give us sec square theta, and by differentiating we can get the value of dx, which we can substitute and we can evaluate this integration to gamma p into gamma 1 minus p. So let's start. So here I'll say put x equal to tan square theta. So this will give us dx equal to 2 tan theta into the derivative of tan theta, which is nothing but sec square theta d theta. Now let's talk about the limits. So if you check the limits, currently it is from 0 to infinity for x. For theta, if we'll check, then x is 0, tan inverse of 0 is 0, and x is infinity, tan inverse of infinity, as I said, it is pi by 2. Now let's substitute all these values in the integration. So I will become integration 0 to pi upon 2. This x raised to p minus 1 will be tan square theta raised to p minus 1. So that will become tan of, and here this will be 2p minus 2 theta upon, here we will get 1 plus tan square theta, that is sec square theta, and the value of dx is 2 tan theta sec square theta d theta. Now guys, here we can cancel the value of sec square theta. Next I'll take this 2 outside and both terms are tan, so we can add the power. So here the power is 1, so that will become 2p minus 1. So I is equal to 2 times integration 0 to pi upon 2 tan of 2p minus 1 theta d theta. And now we have to solve this integration. So guys, if I convert this tan into sine and cos, then I have the limit of integration as 0 to pi upon 2. So I can definitely use the definition of beta function to evaluate the answer. So let's convert that tan into sine and cos. So that will give us 2 into integration 0 to pi by 2. Instead of tan, here now we'll take sine of 2p minus 1 theta upon cos of 2p minus 1 theta d theta. Now we can take this cos in the numerator, so that will become integration 0 to pi upon 2 times, and this is sine of 2p minus 1 theta, and that will become cos of 1 minus 2p theta d theta. So here we have taken this power in the numerator, and when we take it, so that becomes positive. So here the negative 1 will become positive 1 and positive 2p will become negative 2p. And now it is in the form of the definition of beta function. So I'll show you the definition. So here you can see the formula number 4. So whenever we have the power of sin sp and cos sq, we say it is equal to 1 upon 2 beta p plus 1 upon 2 comma q plus 1 upon 2. Now in our case the value of p is 2p minus 1 and the value of q is 1 minus 2p. So here we will say 2p minus 1 plus 1 upon 2. So here I'll write down it is equal to 2 as it is and 1 by 2 beta in bracket 2p minus 1 plus 1 upon 2 comma 1 minus 2p plus 1 upon 2. So guys, here we can cancel this minus 1 plus 1, so 2p upon 2 I can cancel 2, so we'll just get p. Similar here 1 plus 1 2, so 2 minus 2p upon 2. So here 2 cancel, see what we get. So beta is here will get p, and here 2 minus 2p upon 2 cancel, so 1 minus p. And if we'll solve this, then this is nothing but gamma p, gamma 1 minus p upon gamma p plus 1 minus p. So here I've used the relationship between beta and gamma. Now this will give us gamma p, gamma 1 minus p, and here p and p will be cancelled and we will get gamma 1 in the denominator, and we all know that the value of gamma 1 is equal to 1. So guys, in short, we got the value of integration as gamma p into gamma 1 minus p. So if you'll observe the question, then I said you that if we'll evaluate this integration to gamma p into gamma 1 minus p, we can easily equate it with the value of pi upon sin p pi because it is already given. So guys, here we have proved the given result, gamma and beta function, and I'm very sure that you like this video. And if you want to see more videos on beta and gamma function as well as in the engineering mathematics, then do not forget to log into ekeeda.com today itself, and you can enjoy the videos unlimited. So thank you very much. Let's meet you in the next video.